Thank you. Everybody's like, I'm not going to be the first person to clap. Not me. Nobody's going to look at me doing it. Thanks for coming. This will be interesting. This demo more than, and I do a lot of demos, I do a lot of talks. This demo more than any other was really me working on it. You watched me work on it at the very end. Not because it wasn't working, but because I kept on thinking, I wonder if I could add this thing, I wonder if I could add that thing. And so this will be interesting. We'll kind of work through it together. Let me just get a feel for the room. How many people are running Kubernetes today? Oh, okay, like a pretty good portion of the room. How many people are running stuff in production on Kubernetes? Oh, okay, smaller percentage, good, okay. And then how many people are like at least playing with Docker, they're Dockerizing, they're containerizing? Most everybody else is in some stage or another. And then is everybody here like on the test side, or like are you application engineers? Like shout out, like what do you do? Application engineers and testing, well yeah, you work for Sauce Labs, so that goes without saying. What about everybody else? It's like we have, what do you do? DevOps, okay. You're on the DevOps side. I see a lot of nodding, a lot of DevOps people. Okay, I just want to get a feel for the room so that I'm not speaking nonsense. Though I might do that anyway, I mean, no promises. So we're going to talk about how to run Selenium tests with Helm, Kubernetes, and we'll also use Sauce Labs in this example. And I'm going to be using Codefresh to do this because, spoiler alert, I work for Codefresh. So part of what I do is I come up with cool solutions, I go on, I give talks, and then part of the thing that I feature is Codefresh. But these principles really should be useful regardless of the tools you decide to use. And they're, hopefully it'll be educational and useful. Oh, one last question. How many people are familiar with Helm? The same group running Kubernetes in production, no accident there. We'll do like a super fast primer on Kubernetes and Helm. So don't get bored if you know that. We'll be through it super fast. So first, just the quickest of intros to Kubernetes. Basically, you can declare how you want your containers to run, and Kubernetes will just make that happen. You don't have to know how, you don't have to know all the details. Basically, you say like, I want my application to run. It's got these containers. These are the ports. This is how many like copies of my application, instances of the application I should have. And if your stuff is crashing all the time, it'll just start it up again. So a good example of this. This is actually kind of funny. This is an example of how far you've come in your containerization journey if you're thinking this way. I actually know a lot of people who have containerized who are running Java. And one of the biggest jobs you have to do in Java is garbage collection, right? You're always having to deal with garbage collection. Who's got the garbage? Who's going to take out the garbage? Is it my turn? Is it your turn? Who knows? With Java, and a lot of people who containerize with Java, what they'll do is they'll turn off Java collection, garbage collection. Freudian slip. They'll turn off garbage collection, and the pod will suicide and be reborn with no interruption to anybody. And so this is an example of kind of containerized thinking is like, well, look, it takes me half a second to start up my new pod, and I have a bunch of them, so why do I care if one dies because it ran out of garbage? And actually, I just saved CPU time cleaning up garbage for no reason. Like it's just going to go away, a new one will be born. So that's an example of kind of how Kubernetes and containers sort of change the way that you might build and run software. So again, quickest intros. Containers are things which run inside of pods on Kubernetes, and those things run inside as part of a deployment. So you can have lots of pods, each one with their own containers, all copies of the same application lots of times. That deployment can be exposed by a service or another Kubernetes entity. Let's not get it complex. And those run on top of nodes. And what are nodes? Servers. Yeah, that's just a server. Hopefully not this one, but node's just a server. And it could actually be, it could be a VM, it could be a physical server. We don't care, it's a node. So these are kind of the layers of how you get there. And one more thing, images are the thing that run in your containers. And lots of times when I talk about an image or a container, I will use them somewhat interchangeably, but they're not the same thing. It's like the movie is the combination of your DVD and the DVD player. I made it more complicated. It's okay, forget that. Okay. And what is your image? Well, your code is, it's basically some of your code and then probably mostly other people's code, right, that make your software run. So we need to be able to test that. We need to be able to say this stuff is all good before we deploy to production. But we actually have a bigger problem, which is that your application is more complex than that. So the example application I'm going to be using tonight is called the example voting app, and it has 5 microservices. 3 of them are stateless, 2 of them are stateful. So we've got this Python voting app. This is what lets you vote on stuff. We've got this results application, which displays the results. We've got a Postgres database for reading that stuff. We've got a Redis instance for capturing the requests. And we've got a .NET worker in here. So this is a really friendly, polyglot kind of environment that we're working in. And actually tonight, the demo that I put together it's really rad, first of all. It has like a bunch of extra cool stuff in it. And so some of those things I'm going to gloss over, and you might want to be like, oh, I kind of want to hear more about that. So like one of the things that I'm doing is handling the stateful aspect of this, which is something that's sort of complex to do with containers. Or not really, as you'll see. But each of these things is basically a container, right? Or a set of containers, right? I might have a bunch of different instances of this Python container. We don't care. Kubernetes is handling that. We don't care how many there are. It's running at a time. So this is where we introduce Helm. Now, for those that are new to Kubernetes, and you're like, bro, I just needed to learn pods, services, deployments. Oh my gosh. Let me introduce one more thing before your head gets full. Helm is a package manager for Kubernetes. So why is this useful? Well, because I can package all of this stuff into a single, basically, glob that I can say, I want to install this. And it will be like, oh, you want this Python app? Let me grab the container and spin that up. And you want this node thing? Let's throw that to Kubernetes. And I can say, well, this is how they talk to each other. And this is how they deal with storage and persistence. And I can define that all inside of my Helm chart. OK, so this is going to be really useful because in a minute, we're going to be talking about how we use this with Selenium, right? Which is like how do we test against stuff? And the reason that that's important is because, let me back up. Let me back up and explain why this is important. So in a classical sort of engineering environment, this is typical. This should look very familiar. There's like a staging thing that's off of master. I branch off of that. I'm writing my code. I do some unit tests. I do a pull request. This is when code review goes through. And then it deploys onto a staging server. And this is like the first time that it gets the real integration testing. And depending on your environment, it might look a little bit different. If your application is like really robust and you can't run it locally, then maybe you don't have any feedback until it reaches a staging server. This is fairly common. So the problem with this is that it creates this bottleneck where basically you only have n number of staging servers, right? So a concept that I'll introduce is what I would call ephemeral environments. That is one-off environments that pop up and they tear down. And this should sound familiar because we just talked about how pods do that, because this is like a Kubernetes thing. It's like a Kubernetes native way of dealing with environments, which is that like I don't have to care about I shouldn't have to care about building up my entire application and deploying it and tearing it down within a few seconds. It should be easy. And another advantage of this is that it basically means my application is packaged in a way that I can do disaster recovery super fast. So like if your entire production, everything disappeared, how fast could you get it back up and running? Well, if you're kind of in this Helm environment, you're like, bloop, and it's back up, right? So some data stuff, TBD in that, right? And how you deal with your database backend. OK, so what we can do is, sorry, I thought I had one more slide here. What we can do is we can basically eliminate this bottleneck, and we can take all of this stuff, and we can move it to before the pull request. And then we can actually pass all that information into the pull request, so the person who's doing the pull request, they're never reviewing code that's not going to make it to production. Like unless there's a stylistic problem, they're reviewing production-ready code every time. So they waste less time. You're more efficient. OK, so Just looking at the way that Kubernetes defines things, there are a lot of different sort of definitions, but they're all configured using YAML. And this is sort of the relationship between persistent volumes, where basically you create this persistent volume claim, and it's attached to a storage class. And the storage class is basically describing like where the disks are, essentially. And the persistent volume claim is basically naming that and setting the rules for what you're actually going to give to somebody. So you could have a storage class that's used, right, by lots of different persistent volume claims, and then your pods can connect to those persistent volume claims, and that's how they get persistence. That's how they store data, right? Okay. I'm seeing nodding. Hopefully it's not too confusing. Oh yeah, and then there's a persistent volume up there, which is what we actually expose into the claim. So if that's not clear, that's okay. I'm doing a whole webinar on that tomorrow with a company called Portworx. So feel free to tune into that, and we're going to go a lot deeper on the persistence elements of this. And to understand a Helm, kind of some of the stuff that Helm is doing for you, it has this sort of templating element to it, where I can say, if you take out the variables, this is basically just a Kubernetes configuration file, where I'm defining a deployment. But I can reuse that and pass in a set of variables, which then I can like manipulate dynamically, do all the kinds of things there, which lets me basically customize it. So in the application that I'm using, even though I'm doing some really interesting stuff with how I'm dealing with data, I'm using out-of-the-box charts for everything that's not my application. And my chart references those charts and pulls them in with all of their stuff. And all I do is pass it some variables for how I want them to behave within my chart. Make sense? Yes. Cool. Good. Oh, verbal yeses. I like it. So here's what we're gonna deliver, and we'll take a second to look at the application so you can see what we're doing. We're gonna make a commit, and truthfully, it doesn't really matter where we're making the commit. So GitHub, I'm gonna use GitHub tonight, but it could be GitLab or Bitbucket or whatever. We're gonna build the images and the chart. Why? Because what's our application? It's a collection of images, which we put into a chart, right? So we're gonna build the images and the chart. Now, because I want to deal with stateful stuff, and what I want to do is I want to test real application conditions, I'm actually going to clone my live data. Now, I'm using this really cool company's persistent volume. What's their thing called? Was that on this slide? Storage class. Thank you. Thanks, guys. Save me. I'm using this custom storage class, which is really cool because it gives you the capabilities of basically doing like instant snapshots, and they're copy on write, so they take 0 time basically to create the snapshot, and then it only actually starts writing data once they start to diverge from each other. Okay, so that's the way the snapshot works. So we create a snapshot, we clone that live data. And clone is deceptive. I mean, we snapshot it, basically. And then we deploy it to a one-off environment. Why? Because maybe I have 1,000 people working on this thing, and I only have one staging server. Or I don't want to have a set number of staging servers because who knows how many people are working, and all of a sudden I have to like plan for peak number of staging servers, and then I've got a bunch of like a wasted compute time, and then my CFO's coming in here asking me why my compute bill is $500,000 a month, and I'm freaking out. So let's avoid all that, okay? Let's just take it easy. Life is easier than that. We're going to deploy to a one-off environment, so we don't have to care about maintaining some environments. And the nice thing about this is you basically accept that your production instance is another one-off instance. And so you don't have to, it basically means that you're in a position where let me put it another way. If you're doing a blue-green deployment, this could be your green version, and you can just switch everything over to that, right? Because it's a perfect clone of what's running in production. Yeah, question?
How do you deal with the PI data when you do flow?
Yes, how do you deal with PI data? That's a really good question. You should come to the webinar tomorrow that I do with Portworx, because there's a whole, that's actually one of the questions that was planned for. But probably take too long out of here, but it's a great question. Okay, and then we're going to run functional tests. And in this case, I'm going to leave out the JMeter performance testing stuff. I'm going to do the Selenium stuff, and I'm going to use Sauce Labs as my test grid to do that for a couple of reasons. One, I like to have a place that I can store my test results, and Sauce Labs does that really, really well. So if I want to have like screenshots and I want to see the video of the tests and give that to my team, that's a really, really valuable, useful way of doing that and exposing it to people. And of course, they do have just a really great functional grid that we can use, and I don't have to like spin up my own as part of this. And then I'll deploy to production, and the last step, I'll just remove my one-off environment. Okay, so fairly simple. Somewhat simple. Okay, so let's look at the application here really quick. And if people are enterprising, they can interact with it, and we can see the data move. So here is, and this is a public URL, so you're all welcome to go to it. This is a vote on if you like cats or dogs better. So anybody nobody cares to vote, that's fine. That's fine, don't worry about it. We don't have to. There are some results in there already. Let's look at the results. And we'll see that there have been 13 votes. Currently, dogs are winning. Suck at cat people. That's what you get for your ambivalence. Okay, and what I'm showing you now is Codefresh, and we'll get into actually making a change. What I'll do, no, let me show you first, and then we'll have a few minutes to look through things. So in Codefresh is basically a CI/CD DevOps platform, and it's purpose-built, designed from ground up to be Kubernetes native and Helm native. And like, if your goal is to deliver a container to production, then we have streamlined that process to a T. And we've taken a lot of the that kind of container-first methodology into how we built it and how we designed it, so that the people that interact with it are kind of getting the default path of like, this is how you containerize, this is how you do it, this is how you test stuff together, these are the tools that you should be thinking about, this is the way you should be thinking about it. And there are a couple of interesting wrinkles to it. I won't go into everything, but you can see here I've got a bunch of repositories connected. They each have pipelines associated with them, and webhooks that are set up automatically. You can see I've got a bunch of builds in here. We can go and review those. I also have a built-in Docker registry, so I have images and they have annotations on them. So for example, what I can do, maybe what I'll do actually, let's jump over to another account really quick. We'll take a little detour. Detour? Little detour? Thumbs up, cool. Let's say that I'm looking at an example of an application. Let's use this one. No, let's use this one. Nope, I killed that one. Everybody's like, we regret this detour. Why did you make us do it? Okay, let's say that we're looking at an example of an application and we want to understand what's running. You can see I can see the image right here of what's running, and if I click on it, it'll take me to a view of that image that includes all the information about it. So I can see who created it, I can see that it passed unit tests, I can see what the unit test coverage is, I can see it's got a Jira ticket associated with this image, it passed functional testing, and I can see there's a commit SHA. So if I want to understand what change created this image, I can actually jump straight into my version control and see that change. And it's linked to my image. So this is what I was talking about when I was saying like some of the thinking kind of container first, Kubernetes first. Basically, your images become a source of truth, right? They don't have to be a black box. They can be a black box with a bunch of labels on them. And you can pull them down and work with them. But OK, I digress. So digression over. And then, of course, we have that Kubernetes dashboard, which I've shown you. And then we also have this Helm release section where if I wanted to work with Helm, you can see I have a bunch of different clusters here. Here is something that has, this is the application that we're working on, this voting application. And there's a whole history of all the times that the chart has been updated. And any values that change in here will show up. And I can actually issue rollbacks on demand. So if something went bad, I can just roll it back, no problem. And I'm on my way. And I can also work with the chart, see the values, and see what was actually rendered and sent to Kubernetes when I created this chart. OK, that's enough of the pitch. So let's go kick off this pipeline and before I kick it off, let me explain maybe one more nuance to it. Everybody still with me? Or is everybody like, stop going into the details of everything. I want to see big picture. Somebody, I sense hesitance. Okay. Well, let's just make a change. Let's make a change, then we'll come back and look at it. So I've got my cats versus dogs thing here, and I was looking at the voting page. Okay, so I'm just going to add some text here. Pretty small change. We're just gonna make a little change to the template. Let me go into this bad boy, and we'll go down to where it says those words processed by a container ID, and we'll say hi sauce labs. Woo! All right, we'll write that, and we'll write our message. All right, and it's off to the races. So we'll see the build kickoff here pretty much immediately. Probably already started. There it goes. It's initializing. Now, the first thing it's going to do, remember my application actually has 3 different Docker images, right? I'm using a mono repo in this case. So the first thing it's going to do, you'll see it'll clone the main repo, and then it will kick off a matrix build. We'll say, go build all 3 of those images at once. I don't want to wait. So it's checking, it says check build concurrency, and then you see these 3 new builds just kicked off. So from there, let's jump in and see the progress. It's seeing that the images didn't exist, so it kicked off the rebuild. Now when we build the images, we're going to cache all of the layers, right? So that means that the change that I just made, it's very small. So building those Docker images shouldn't take a long time. It should be super fast. So we not only cache the layers, but we actually have a lot of kind of interesting things that we do to optimize the process of pulling those layers and identifying which ones need to be rebuilt, and then reusing volumes that had the cache stuff on it on different pipelines. We do that automatically. So there's a lot of optimization in there, and it took 52 seconds to build all 3 images. Now it's going to create the volume snapshots. Those are done, and now it's going to deploy to staging. And just for funsies, we can pull up and look here in Kubernetes. You can see now it's pulling up these staging environments, okay? And if we were to pause it here and go and look at the IP addresses for this, we're gonna wait for it to expose the endpoint here. The slowest part of this whole process is actually just getting an IP address. I could potentially just set up an ingress that just sat there and maybe had like a variable associated with it, so I wouldn't have to wait for it. But that was like item 10 on the list of cool things I wanted to add into the demo right before I did it, so I didn't get to that part. So once it has the IP address, it'll pass this on, and we'll execute the sauce labs call. And the way that looks, and this will actually explain, let me reload that. What this is going to do, and normally I put the build steps under version control, but for the sake of the demo, I've just kept it all in platform, so we're not jumping around more. What it will do after it grabs the endpoint is it will build the test image. So that's a different Docker image that has all of our tests in it. And then it will execute this functional tests step. Oop. Yep. And didn't mean to do that. And that will basically say, I'll pass in my sauce username and key, and then it will execute my Python-based app script, which will go and talk to Sauce Labs, tell it to execute, and then afterwards it records the test results here, and then I can record those onto the image potentially as something I could do, but I didn't quite finish that step either. And now it's executing the functional steps. So there's the endpoint here. So if we look at this, it'll be briefly available before it goes away. And we can see it says Hi Sauce Labs. So good, we're off to a good start. It's got the right change in it. These functional tests will go pretty quick. They're set up to also run in parallel, which is another kind of nice Sauce Labs Z feature that you can do. And then we'll deploy this chart onto production. And we had that live data in our tests. So we were actually working with the real deal, right? And this has executed successfully, and we can see that it's rolling out. So we were able to get our change. Let's go double check. Hold your applause. Slow down. I know you're on the edges of your seat. You're thinking, I don't know if it worked. Maybe he faked it. I don't blame you. Let's go look at the voting app here, and we'll see that it did indeed get our change. Thank you very much. Thank you. Oh my gosh. Wow. Woo. Thank you. Such enthusiasm. You guys had too much pizza before this started. Everybody's kind of sauced out. So basically, by bringing all these elements together, what we have is a totally scalable build and test infrastructure. I could throw 1,000 developers at this tomorrow and have a high degree of confidence that we'd have no challenges, that it would scale to meet demand. Because again, I'm running a Kubernetes. This thing is set up to scale automatically. Job's done. I don't have to worry about it. So this puts you in a really good position where you're not going to be running around and trying to maintain servers and trying to, make sure that server versions are, up to date, and you're updating servers, because you're maintaining the images. The images are being changed all the time, right? They are fleeting. So that stuff can happen automatically, and you can deal with things like underlying dependencies, kicking off builds, kicking off pipelines, and everything can be validated. And again, before we even get to the idea of like a staging server, right? We can basically one-off that stuff, and we could also self-serve it. So for instance, if somebody looked at this chart and after things had run and maybe it hadn't been deployed yet, and they were like, I actually kind of wanted to look at some of the behavior, they could go into this Helm chart section and find the chart that had been deployed, and they could just hit install and they could pull it up and go and look at it, right? So puts people in a position where they can self-serve things, and basically gets all of your team on the same page. And again, we're using live data. We're not using dummy data. We're using a snapshot of the live data. It didn't take any time at all to make it. I mean, in that build step that we run, where we have this create volume snapshots, it executed in 6 seconds. Most of that time was to turn on the Docker image that's doing it. And this is actually another clue about how this pipeline is working. Every single step in this pipeline is its own container. That means I can have different versions of different software running in different steps, and it's just fine. Now there is a volume attached to all of those steps, so that way I can write variables into that layer and then pull them and pick them up going down the pipeline, right? And so it's all available, it's all right there. And then, as I mentioned before, that volume will actually be reattached to your next pipeline when you run it, so that you can pull all the cache. It's actually a separate volume, but basically there's a cache volume that's attached to your pipeline, so that the next time you run it, you're not pulling artifacts without needing to. Maybe you've got like Gradle pulling a bunch of like Java stuff. It can just be cached, right? So you don't have to re-pull it again, because there's no reason to if it didn't change. So this gives you an idea of how all these elements and components can work together to make something really functional. So with that being said, we missed. This was the setup that was going to make you smile through the whole demo, but we did it afterwards, so my bad. One thing that we do offer is all this stuff was built on top of GKE, which is my personal favorite. I really, really love GKE and the way that they've implemented it and how easy it is to use. And to help you all get started, we've partnered with them to offer $500, up to $500 in GCP credits. If you've never tried GCP before, you grab those $500 credits, set up a cluster, and it can run for quite a while. My mom's blog is like running on Kubernetes, and she doesn't know what that means, but she's happy that I'm happy, so that's good. So that's the URL to claim that. So questions?
So we kind of got married with Amazon. Do you support the ECS?
Yeah, we do support ECS, deploying to ECS. A lot of the Helm stuff doesn't work with ECS. I mean, that's just, Helm is a Kubernetes entity, and so your experience will differ. But we do have an out-of-the-box step for deploying to ECS. And what we find is we actually get a lot of people who are in sort of a migration process, and they want to have both capabilities, and so that's one of the reasons we support it.
So we could like run tests like in lower environments on Cube and then just deploy it to ECS if you want.
Sure. Yeah. Absolutely. Yeah. You could do. Yeah. You could mix environments. There's actually another option here which I didn't show. Some of you noticed that there was like a Docker Swarm option which I glazed over. Inside of a pipeline, you can actually spin up a composition. So another version of this demo where we use just Selenium is we actually have a step where we spin up a test grid inside the pipeline. It doesn't go to any external. It runs on the infrastructure where the pipeline is, spins up the test grid, runs the tests, and then shuts down.
What is like the highest degree of parallelism we can achieve?
What's the maximum number of parallel stuff we have going on at any time? I mean, it's in the thousands. We're set up for total scale, and you don't have to use our cloud either. I mean, you can use Codefresh on your own infrastructure if you wanted to. Our cloud service is the most popular because it's just the most easy. But we have customers like HP. They want to run it inside of their own bare metal thing, and they want to control it. That's fine. Go do that. But yeah, good question. Yeah, parallel concurrency isn't a big issue for us. Other questions? None? That was easy. Okay. Everybody find it useful? Thumbs up, thumbs down? Cool? On the Radometer? Yeah, okay, thank you. I crave good feedback, thank you. All right, well, I'll be hanging out for a few minutes afterwards, and then I don't know if do we have another follow-up, or that's it?
Unless anybody wants to do a impromptu demo? No?
I have a sub question. So how much parallelism can we do with source labs?
Well, at the risk of being commercial, as much as you want to buy. Okay, I was commercial. Depending on how you configure your tests, to run them in parallel, we've got customers kicking off thousands of instances at the same time.
Gotcha, perfect. Cool. Any final questions? Or on Sauce Labs too?
So what about this 500 credits? So what condition? Like, do you have to provide credit card? It expires like which time?
Oh, like what are all the details of the $500 credits? So I'll tell you a couple of things. One, Google has to approve giving all the credits. They have like a manual review process where they look at your email address and they're like, yahoo.com? I don't think so, buddy. So use your work email address. You'll have a better chance of success. Also, if you've already created a Google Cloud account, your chances of success will go down. And then they'll have details on what their expiration is. And I think it's at least 6 months. I can't remember how long it is. So there's, yeah.
It's a year on a limited account, and if you upgrade to a regular account, the $300 or $500 apply for 2 months.
There you go. Good answer. Thank you.
Yeah.
And what you'll do, this URL has instructions. Basically, you have to set some things up, and then you'll get an email with kind of how to claim and apply for the credits. Cool. Well, with that, thank you very much.